2, 3. This is on the product and quotient rules, and it's also going to have some higher order derivatives in there. So let's go ahead and, oh crud. I want you to think about those two questions up there.
I bet you just distribute that 2 to each one of those things.
I bet you teach that.
I used to.
Oh, who said foil? Okay, technically, for the first one you can foil.
That's what I meant.
Oh, the second one, binomial theorem, right?
Okay?
The second one's
Because
binomial theorem.
when you think about it, what you can do on that first one is you can take x plus 2 times x plus 2, right? And then you can FOIL it out and then use the rules that we know. Now the question is, how do you get down to the derivative of x plus 2 to the 10th? Well, when you think about it, yeah, you could use the binomial if you remember it. But my guess is you don't remember it. So when you think about that, that's going to take you an awful long time, right? Then I want you to think about this. How would you find the derivative of that? So obviously we haven't learned all the ways to find derivatives. That's what my point is. And so there are going to be those exceptions in which we're going to have to learn some other ways to find derivatives. This way that we have right here is going to be what we're going to be learning in section 4. It's called the chain rule. Okay, and we're going to learn how can you find the derivative of a quantity to a power so that you don't have to multiply it out. This we're going to learn today is called the quotient rule. Okay, so we're going to start first of all with the product rule. We didn't look at an example for the product rule, but basically you don't need to necessarily write down all these paragraphs. What you could do is you could write down this. And then if you would want, I have in blue right there. This is kind of the shortcut way that I like to think about it. But it says the product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second function times the derivative of the first. So the formal way of writing that is what I have boxed. A little easier way of writing that is what I've written down here. First times derivative of your second plus second times derivative of your first. That's what the d means. D means derivative. So first d second plus second d first. Now I'm going to show you a way that I think is going to work real slick. Okay? And so once everybody gets that down, we're going to look at an example. Oh, you'll do that. What, an hour? Okay. Okay. So let's go ahead and look at an example. Now what I'm going to do, okay, is I'm going to leave these two up here. And then what I want you to do is I want you to find the derivative of each of the parentheses below that set of parentheses. So basically what's going to happen is you should have like a 2 by 2 thing. You should have 2 rows and 2 columns. So what's the derivative of 3x minus 2x squared? What's the derivative of 5 plus 4x? 4. Now what we're going to do is we're going to do, you might think it's cross multiplying, it really isn't, but we're going to multiply and make an x. So I'm going to take this parentheses times 4. Okay? So I've got 4 times your 3x minus 2x squared. Then I'm going to add that to, because if you remember add it to, that times that. Now, you do have to FOIL out that last bunch. Okay, there's just no easy way around it. So now we need to simplify. So to simplify, I get 12x minus 8x squared. Plus what? Yep. Okay. Okay. Good. Your final step will be to go ahead and do like terms. So what will your derivative be? Negative what? Try again, close. Negative 24x squared plus what x? Okay. So now I know some of you are saying, well, could we just FOIL out from the start up here and then find the derivative of each individual term? And the answer is yes, you can. No, I mean, it's obviously, it's going to probably be a wash in terms of the time you've spent. The reason why we looked at that is because we're getting ready to deal with problems like this. This one, you can't FOIL them out. You have to use the product rule here. Okay, you've got two quantities. It's the only way to find the derivative here. You have to use the product rule. So you have your first term here, and you have your next term here. So if you remember, we're going to write the derivatives right below each of the terms. So what was the derivative of 3x squared? What's the derivative of sine? Cosine. So now we're going to multiply on the diagonals. Okay, so I start here. So my first term will be what? 3x squared times cosine x plus this diagonal, 6x sine x. And that's all you can do on this one. That is your answer. Okay? So when you have trig functions thrown in there, you're going to have to use the product rule. So now what we're going to do is we're going to look at the following. Now if you look at this one, I'm going to do the product rule where? The 2x times the cosine x. So my terms are here and here. So what's the derivative of 2x? 2. What's the derivative of cosine? Negative sine. So we're going to start by multiplying on the diagonal. What can you tell me your first part of your derivative is? That's what I was looking for. Good. Negative 2x sine x. Plus what, folks? 2 cosine x. Okay, now that is just the product rule, and we still have, good grief, we still have one additional thing we need to find the derivative, and that's this. Okay, so I have minus 2. What's the derivative of sine? Cosine. So now, let's think about that. Can I simplify that any? Really?
Plus 2
There's your final answer, because those cancel. So that is the product rule. We're going to now look at the quotient rule. So the quotient rule basically states, what do you do if you divide? And so the quotient of f, or the quotient f divided by g of two differentiable functions f and g is itself differentiable at all values of x for which g of x does not equal 0. Denominator can't equal 0. Moreover, the derivative of f divided by g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. So we've got a nifty little way to remember that. And this is what I want you to remember. Okay? Low d high minus high d low all over low squared. Key here, you have to remember, I start with low and low. Low d high minus high d low over low squared. So it's kind of like one of those sayings if you get in your head. Low d high minus high d low all over low squared. Okay, so low d high minus high d low over low squared. Remember that. So let's go ahead and look at an example of that. Here's my quantity. Now what I'm going to do is I'm going to individually find the derivative of both the numerator and denominator, and I'm going to put that derivative next to them. So derivative of 5x minus 2. 5. What's the derivative of x squared? 2x. So once again, we're going to look at diagonals. Remember from the formula for quotient rule, where do I start? Low. So I'm going to take low d high. Okay, so I've got x squared plus 1 times 5 minus, so that's what's different. Go on the quotient rule, you subtract. Minus what? High d low. Okay, so I've got my high term, which is 5x minus 2, times my d low term, which is 2x. And all of that is divided by low squared. Okay, low d high minus high d low over low squared. So now what I need to do is distribute and simplify. So when I distribute here, I get 5x squared plus 5. All right. What do I get here? Minus 10x squared plus 4x. Why is it plus 4? Because each of those, the signs change with that negative sign. So really my final answer will be negative 5x squared plus 4x plus 5 all divided by x squared plus 1 quantity squared. That's the quotient rule. Low d high. No, you do not have to FOIL out the denominator. In fact, I would prefer you not. Okay, low d high minus high d low over low squared. Now I believe I've got another example we're going to look at. Yep. Find the equation of the tangent line to the graph of. Now remember, when we find the derivative, what are we finding?
Tangent line.
The what? Slope of the tangent line. So once we find the slope, we know that it goes through this point. So we will have the slope and a point. So that's where our equation for our line is going to come into play. So now the question is, how do we find the derivative of this mess?
Answer negative 1.
Okay. Well, not yet. We've got to find the derivative first. So what we need to do is I'm going to look at it this way. And right now, in order for me to find the derivative of this, I need to clean it up. I need to simplify. I've got a fraction within a fraction. That's that. So what I'm going to do is I'm going to multiply this by x over x. So really, this becomes 3x minus 1 all over x. Now, I'm going to show you a little trick that I use, and you will use it a lot this year. When you have a situation like this, you can combine those two and make it a fraction. So your numerator will be 3x minus 1. Your denominator is going to be x times x plus 5. So when you have those two denominators there, you combine them and make them 1. So really, the whole thing simplifies to be 3x minus 1 all over x squared plus 5x. So now I need to find the derivative so that I can find the slope. So to find the derivative of this, I get to use the quotient rule. So derivative here of 3x is 3. What's the derivative of x squared plus 5x? 2x plus 5. So I start with what term? Low. Okay? So I take low, d high, minus high, d low, over low squared. Now some people think you can cancel off your x squared plus 5x in both the top and the bottom. You can't, because each term does not have an x squared plus 5x. So let's simplify. Here I'm going to get 3x squared plus 15x. Okay? Here I'm going to have minus a big bunch. What does that come out to be? 6x squared minus 2 plus how many? 15, so really it'll be a net of 13, and then minus 5. So what I'm going to do now is distribute my negative. So really I get negative 3x squared plus how many x? 2 plus 5. And then all of that is over x squared plus 5x squared. Now that's the derivative. Okay. Now that, if you notice, this is finding the equation of the tangent line. So this implies the slope. So at negative 1, 1, I'm going to plug in negative 1 for x. And that's going to tell me the slope. Okay, that will tell me the slope of the given line. So let's see. I have negative 3 times negative 1 squared, which is going to be what? Negative 3 plus what? Negative 2 plus 5. All over. Let's look at the denominator. Negative 1 squared plus negative 5 is what? What do you get on the top? 0. So what's your slope? Your slope is 0. So if you have a slope, vertical line, horizontal line, what is it? Slope is 0.
Horizontal.
Horizontal line. So horizontal line goes with y, right? So your equation should be what? Y equals 1. And that is your equation of the tangent line. Another way you could have done that. Okay? Once you find a slope of 0, you do point slope form. So you could have done point slope, which would have been y minus 1 equals 0 times x plus 1. And that would have gotten you the same case. Now the reason why I showed you that is because you're going to have some of those on your homework. Now what we're going to do is we're going to leave the higher derivatives of these trig functions and the higher order derivatives to tomorrow. Okay, here you go. There's your assignment. Okay. So probably expect a short quiz tomorrow. I'm going to probably throw some product and quotient rules in there as well.